Hello, students. Today we are going to learn about fuzzy prepositions. The basic assumption, whatever the crisp logic we have, is only two preposition. Either it is true or false. So this is called as classical two-value logic, and which can be extended with multiple value logic with three. So that is true, false, and we have indeterminacy. So indeterminacy can be implied with the help of the value called 1 by 2 or 0.5. Now, two-valued versus multi-value logic, how we are writing three-valued operators for this particular thing operation. So we have the A, B. So if you observe here, A values will have the input as 0, 1, and 1 by 2. B also same. So this is and, this is or, and this is negation, this is implies, this is equal to. So we know that and operation. Okay. So A or B. So both should be same. So it is 0. 0 or 1 by 2. So if you take here, this is OR operator, it is 1 by 2. So anything should be positive. And negation is 1 minus 0, that is 1. Implies is maximum of these two values, it is 1. That is equal, both are equal, and equal to also both are equal. So this will be like same how we are calculating for your crisp logic. Only the thing is the value will be changed according to the these input values. Now, what are the connectives? Fuzzy connectives are like and, or, not, implication, and equal to. So this is and symbol, or symbol, not, implication, and equal. So we'll see what are the formulas and how to use these connectives in our fuzzy values or fuzzy connectives. Now, these are the fuzzy connectives, same, negation, not, negation of P. Here, P is your preposition. So, 1 minus T of P. So, T is the value, T of truth value of that particular P. Or is P or Q, maximum of T of P and T of Q. And is minimum of T of P, comma T of Q. Implication, we can write in these two all equations also. P implies Q or negation P or Q, or can be calculated as max of 1 minus T of P, comma T of Q. Okay, finally equality. So it can be written as P equal to Q, or P implies Q and Q implies P. So this can be calculated with the help of 1 minus T of P minus T of Q modulus. Now if you see the example, one example. So I'm taking Ram is honest. If it is 0, I'm taking as absolutely false. Partially false means it is 0.2. Maybe false or not false, it is 0.6. So we are assuming some values for this particular honest, whether Ram is honest or not. So according to this, the linguistic variable for Mary is efficient is T of P equal to 0.8 and T of Q equal to 0.6. Now we'll calculate the Mary is not efficient. How to calculate this is negation of P, that is 1 minus T of P. So what is 1 minus T of P? 1 minus 0.8 is 0.2. Mary is efficient and so is wrong. So both are efficient, we are telling. So we'll calculate minimum of T of P, comma T of Q. So what is the minimum of T of P and T of Q? It is 0.6. Either Mary or Ram is efficient is or operator. So we have to go for the max. So what is the maximum of both of these values? It is 0.8. Implies we have to take for maximum of 1 minus T of P, comma T of Q. So what was the 1 minus T of P? It is 0.2 and T of Q is 0.6. So what is the max value? It is 0.6. So like this, we can calculate various connectives using these values. Now, what is the difference between crisp and fuzzy prepositions? So in the crisp prepositions, we'll have only two values, either true or false, but fuzzy prepositions will range from 0 to 1. So this is a fundamental difference between both the classical and fuzzy prepositions. Now, what are implications? So X implies Y. That is, if X is true, then Y is B. Okay, if X is A, then Y is B. Or if X is Y, then Y is Z. Okay, whatever it may be. So these are the implications. In this equation, where A, comma B are the linguistic variables on the fuzzy set A, whereas B on the universe of discourse of X, comma Y. And if X is A is called the antecedent or premise, while Y is B is called as the consequence or conclusion. So this way we will write the fuzzy implication. So the example for fuzzy implications are, if you see here, if the pressure is high, is the your implication where it implies that temperature is low. So this is the premise, this is conclusion. If mango is yellow is the premise, this mango is sweet, else mango is sour is the conclusion. Similarly, if road is good, then driving is smooth, else the traffic is high. So this can be written as R A implies B. Okay, it will be Cartesian product of the A cross B. We can calculate the Cartesian product. So for this A cross B. So example for the implication, we have two things. One is pressure and temperature. So pressure values are given as 1, 2, 3, 4. And temperature, we have 10, 15, 20, 25, 30, 40, 35, 45, and 50. So just how to calculate this particular relation. So T of high and P low are the two linguistic variables. So the value of temperature high for 20 is 0.2, 25 is 0.4. Like that, we have defined all the values over here. And for low P of 1, it is 0.8, 2 is 0.2, 3 is 0.6, and 4 is 0.5. Now, how I'll calculate this one? So the relation can be calculated, the Cartesian product, that is minimum of this one. So if I write here 1, 2, 3, 4, and 20, all the temperature values, if you see here, so 20 is 0.2. For 1, it is 0.1. So which one is minimum? So 0.2, 0.8. It is minimum is 0.2. Now 20 with the 2. So 20 with the 2. So here it is 0.8 and it is 0.2. Which one is minimum? 0.2. So we have written here 0.2. 20 with 3. So 20 with 3, 0.6 and 0.2. Which one is minimum? 0.2. Similarly, 20 with 4. Okay. 1 second. 20 with 4. Yeah, 20 with 4, it is 0.2 and 0.4. Which one is minimum? 0.2. So like this, if you go for the next one, 25. 25 with 1, it is 0.4 and 0.8. Which one is minimum? 0.4. So like that, we will calculate all the combination of the Cartesian product. So if temperature is 40, then what about the low pressure? So when you take the temperature is 40, the low pressure for each and every, the pressure 1 is 0.7, 2 is 0.7, 3 is 0.6, 4 is 0.4. So the low pressure will be like this. So this can be calculated with the help of this multi-valued logic. So the interpretation of the fuzzy rules. So rules can be written like this. Fuzzy rule A implies B as A coupled with B, or A entails B. Now we have so many operators or so many equations for calculating these particular rules. So first one is T-norm operator. So if you see the T-norm operator, A implies can be written as A cross B, which can be calculated as mu A of X into mu P of Y. So we can use anything. In the previous example, we have used the minimum. So we can use anything. So this one we have used, that is T min of A comma B equal to minimum of A comma B. Next one is algebraic product. You can go for this one, exactly this one product. So T-norm operator, this norm can be any of this. You can use anything. Okay. Algebraic product is A comma B. So you have to multiply A into B. Bounded product is the rule. So BP of A comma B equal to 0. Okay. Or A plus B minus 1. So this depends on your A comma B values. Drastic product is DP. So A if B equal to 1, B if A equal to 1, 0 if A comma B are less than 1. So accordingly, this particular T-norm operator, you can use minimum, algebraic product, bounded product, or drastic product. So based on the T-norm operators, we can use anything. So here fuzzy implication function. So mu R of X comma Y equal to F of mu A of X comma mu of B equal to, with A equal to mu of X and B equal to mu of Y. So you can use any two-dimensional membership functions. So interpretation of A coupled B. So when we are talking about the min operator, so this is the minimum operator, A implies B. So we can use A coupled with B or A entails with B. So previous one was A entails B. This is A coupled B. So this can be calculated as Mamdani rule. So here X cross Y mu A of X, or so mu B of Y. So whenever we are getting any AND operator, we have to go for the minimum value. So by basically F min of A comma B. So whenever you get AND operator, you have to go for the minimum values. Next, the same algebraic product is called as Larsen rule. So just you have to write the products AB equal to A into B, AP equal to A into B. So similarly, bounded. So as we have seen the value, if you see here 0 or A plus B minus 1. So if you take 0 or a plus b minus 1 such that x comma y. So directly first one you substitute, or means again what we have to do, maximum value. So mu of x plus mu of b of y minus 1. So you'll get the x comma y. So drastic, as I said, you have to go for this particular. This is symbol for drastic. A if b equal to 1, b if a equal to 1, 0 otherwise. So these you can use. These t-norm operators can be mentioned for interpretation of the operators. Okay. So next one is A entails B. So previous one was A couples B, here entails B. So in the entails B, we'll write A implies B is A complement union B. This is material implication. Propositional calculus, same thing I'll write as A complement union of A intersection B. Extended proposition calculus. So these are the formulas. A complement intersection B complement union B. So next one is ZA arithmetic rule, or okay, the arithmetic rule. So please you remember all these formulas. These are very important if they ask in the exam to write ZA arithmetic rule. So you have to mention this one. So what was the ZA arithmetical rule? This one. 1 and 1 minus a plus b. So same 1 and 1 minus mu of a plus mu of b. So ZA max-min rule. So this is the max-min rule. So what is the rule here? 1 minus a or a and b. So you have to remember these formulas. So RMM equal to x cross y, 1 minus mu a of x or mu a of x and mu b of y such that x comma y. Okay. So these rules, if you remember, you can easily implement. Boolean fuzzy rule. So Boolean fuzzy rule FBF is 1 minus a. V is means your or B. So 1 minus a, you have to subtract the a value from 1 and you have to calculate the maximum of V. Okay. So here or means you have to go for the maximum value. So Gaussian fuzzy rule. So this is a rule. So where you are going to calculate the product of A into B, where if A is less than or equal to B, B by A if A is greater than B. So this you have to remember. So these are the various rules which we can implement on your fuzzy cells. So in order to calculate the implication. Okay. Now, coming to the ZA max-min rule. So this is the formula already we have seen in the previous slide, ZA max-min rule. So this particular rule. So we are going to do this. So what is the formula for this? So just remember A cross B union A complement cross Y. Now, suppose if you have values x equal to ABCD, y equal to 1, 2, 3, 4, and A value is given, these are linguistic variables, A comma 0 0.0, 0 0.8, C comma 0 0.6, D comma. So same. Now we are going to calculate this particular thing, A cross B union A complement cross Y. Now how to calculate the A cross B? So according to this universe of discourse are 2 and A values, B values, and just we are going to calculate the A cross B. So how to calculate the A cross B? So remember, whenever you're talking about A cross B, in the previous example also, we have took the minimum of mu A of x comma mu B of y. Okay. So this is the cross product. So in the example A comma 1, it was 0 comma 0 comma 0.2. So minimum is 0.0. A comma 2 is 0.0 comma 1.0, it is 0.0. So like this, if you go for B with B 1, 2, 3, 4, similarly C 1, 2, 3, 4. So you have to take the C value with 1, C value with 2, C value with 3, C value with 4, and you have to calculate the minimum values. So when you calculate the complete minimum value, we will get the product as A comma 1 is 0.0, A comma 2 is 0.0, 3 is 0.0. Like that, we will calculate the complete A cross B. Next part is we have to first calculate the A complement. So how to calculate the A complement? A complement can be calculated as 1 minus A. So what is 1 minus A comma 1 minus 0, B comma 1 minus 0 0.8, C comma 1 minus 0 0.6, D comma 1 minus 1.0. So you will get the values of A as 1.0, 0 0.2, 0 0.4, 0 0.0. Now, next part we have to calculate for A complement cross Y. So when I calculate A complement cross Y, so A complement is 1, 1.0, comma 1. So like this, I have to calculate all the minimum values accordingly, how we have calculated for A cross B. Finally, I'll get A complement cross Y. So this is a pair where I'll get the minimum values. Finally, we have to calculate the union. See, we have calculated A cross B. and we have calculated A complement cross Y. So maximum union. What is a union? I have to calculate the max. So max of A cross B and comma A complement cross Y. So here A comma 1. A value is 0.0, 1 is 1.0. Okay. So maximum of this one. So here A comma 1 implies this is A cross B and this is A complement cross Y. So what is maximum? 1 comma 1.0. So like this, we'll calculate for A comma 2, A comma 3, A comma 4, B comma 1, B comma 2, B comma 3, B comma 4. So finally, I'll get the result. So this is A cross B, that is A and B, that is A and 1 minimum value. A complement cross Y. So A complement value minimum of Y. So I'll get this matrix. Finally, I'll find out the union of both A cross B union A complement cross Y. I'll get the result. So this is a result how I can calculate the particular thing using the ZA Maxmin rule. So one more example. So this is this one. If X is A, then Y is B. X is A, then Y is B. A cross B. There, wait. Yeah, A cross B union A complement cross Y. So same thing. You have to calculate for both the values. So this is one simple example what we have done. Now, if X is Y, if X is A, then Y is B, else Y is C. See here. If X is A, then Y is B, else Y is C. So here I'm changing here. Previously it was A cross B union A complement cross Y. So it is changed to C. So this we have to calculate. Okay. So how you are going to calculate here? Union means maximum of these particular cross products. So same thing here it is implemented. So what we have done, first we have to calculate these are the values. First we have to calculate the A cross B, then A cross complement C, I got it. Then R equal to A cross B union of A complement cross C. So this will be the result. So like this, we can use any rule according to your implication. So if in the exam, if they ask about ZA Maxmin rule, this is a procedure. If they ask for any other rules, you have to implement according to the other rules. Thank you.